I'm Tony Sklar with bnetTV. We are here at the Small Cell Global Congress, and I am speaking with SkyFiber's Mr. Geraldo Gonzalez. How are you today, sir?
Fine, thank you. Thank you very much. Thank you for the opportunity to be here.
Thank you very much for coming on the show. I appreciate that. For all the people out there in bnetTV land, why don't you give us a brief overview of SkyFiber and what you're doing here at the conference?
Sure. SkyFiber was a company founded 12 years ago, and they require additional investment, which some group of investors finally did it about 4 years ago. I came into the position of CEO and president July last year, and my main goal was to have a product that was fully reliable, that overcome all the situations that in the past had the free space optic systems. And we finally have a product fully approved, fully certified back in March, and so far as today we have close to 100 installations.
So what is SkyFiber? What is that product? How does it differ from regular fiber or other such connections?
We would consider this as a wireless fiber optic, and that's an application for those locations where it's very difficult or very expensive to install fiber. So in that respect, if you have to cross, for instance, a river, rather than to dig under the river or to put a long extension, you put our radio, which behaves in a way like a microwave, but with laser. So it has light that does not require any frequency permit, nothing at all.
So what type of line of sight, how high, what are some of the logistics that are involved that you have to maintain? Is there a weather issue at all, or is it something that, you know, if there's a break within the beam for a short period of time, a bird flies through it, that inevitably it reconnects?
That's exactly the problems that free space optic had in the past. What we have done and developed, and is fully proven, is what we call in the microwave industry forward error correction. That allows that if some birds get into, or if some object pass onto the beam, the signal does not get interrupted. Two things. The first one is the signal into a buffer, and then once the birds pass through, then the signal is retransmitted again. The capacity that we have is up to 1 gigabit, which is the highest capacity that we have right now in the industry for this kind of radios. And we also have auto-alignment situation being done automatically by software, which allow to compensate the movement of buildings and towers. Another important aspect of this is weather. In terms of weather, radios in the high frequency, 60 gigabits, have problems with rain. Our system does not have that, especially because what I mentioned on the forward error correction issue, we can compensate one of the heaviest rains. We have been testing our system in Thailand, in those locations where the rain is really, really heavy, no problem at all. Storms, sandstorms, we have proved that one also in Abu Dhabi and the Emirates, and the problem has no problem at all. The only problem and the challenge that we have is fog. Being light, fog behaves like a mirror, so it reflects the signal. And in that particular situation, we have an automatic fail switch that once the system detects that there is one obstruction because of the fog, or obstruction permanently for one object, let's say they are installing a billboard, and in that situation they block the signal, it switches automatically in one microwave radio. One of the applications that we have is pretty much extend the capacity of the existing microwave network. So we recommend that the people do not remove those radios. They use this as an additional capacity on the radio, and also to use them as a backup when we have this situation on fog.
Geraldo, why is it important to come to conferences like the Small Cell Global Congress?
Well, first of all, our system it's pretty much designed to complement fiber optic. One of the key issues nowadays in the industry is the demand of capacity. We strongly believe that the most important part in the backbone is to have capacity. That capacity is provided with fiber optic. Then our system is a complement for fiber optic. If you compare the price to lay fiber in a metropolitan area, it really costs $20,000-$25,000 a mile. Our system costs definitely less than half of that. And what's important for us to see what applications can we have in this small cells application. We find out that our product will be probably overpriced for the applications that they are looking for. So we have in consideration that issue, and we have in the design board one product that could meet these requirements in a year from now.
Geraldo, what's the maximum distance that you can transmit?
That's an important issue. In order to guarantee carrier class, at least 5/9 of reliability, we guarantee that the system performs properly at, let's say, 1 mile. But we have systems working in the desert, for instance, up to 4 kilometers. But in order to be sure and to meet this carrier class commitment, which is basically what we have to commit based on the fact that we are an extension of fiber, we say that the maximum distance is 1 mile.
Fantastic. Geraldo, thank you very much for taking the opportunity to speak with us. Fantastic product. You're well positioned within this market space to continue to be part of the ecosystem.
Hope to see you in the near future to say, hey, we have something also for small cells.
I like that. I like that very much. I've been speaking with SkyFiber's Mr. Geraldo Gonzalez here at the Small Cell Global Congress in Berlin. I am Tony Sklar with bnetTV.